Hello, everybody. My name is Chris Hodges. I'm a software engineer at Dropbox. I have not landed anything on the moon recently, but hopefully we can give you some interesting insights to what we're doing. It's really cool to see all the different ways that Grafana is used across so many different industries. I work on a team that provides logging, tracing, error monitoring, and dashboarding for our main production environment. And I work closely alongside another team that owns our custom metrics stack called Vortex 2. Both of these teams are here today at GrafanaCon, and whether you're interested to learn more about our observability stack or you'd like to talk best practices, we'd love to speak with you. Back in 2022, we launched Loki as our centralized platform for unstructured logs. And since then, we've learned a lot about maintaining it and scaling it, and I'm excited to share our experiences with you, both the successes and the challenges. And, clicker. I will try to save some time at the end for Q&A. But I hope whether you're a user, a contributor, a maintainer, or in management, you'll come away from this talk with a better understanding of what it takes to operate an observability platform at scale. Okay, I want to start with a story, and I apologize for my AI-generated book cover here, but I'm a dad, and this particular story reminded me of a particularly gloomy children's book. So to give you the background, this was about a year after we had launched Loki. We had a new engineer going on call for the first time. And what on call means is holding a pager and being available 24/7 for a week to answer incidents or alerts that are coming in for the different services that we own. And so pretty short into this on-call rotation, a couple alerts come real quick next to each other. One is Loki is unavailable, and two is our error monitoring system is down. So this gets escalated, and we are very quickly thinking there's probably something bigger going on here than just with our services. And so we go check the Slack channel where we kind of monitor incidents across the company. And to our abject horror, what we found was that the network team was telling us they'd lost connectivity to the data center where we were hosting Loki. And, we had considered a data center outage as a possibility when we were rolling out Loki, but it had just never risen up in priority enough to get put into multiple data centers. And now we were paying the price for that. And so it was hard because we have a data center's down, we have a lot of engineers who need access to their logs, Loki is down, we're giving them not so great workarounds for how to get to their log data. And so, this was kind of a low point. Didn't feel that great. All right, so as far as post-incident analysis, we do this in a pretty standard way and look at it across 4 different areas. So the first two, detection and diagnosis. Detection is, how did I find out that the service went down? Did a user have to tell me about it? Did I happen to stumble upon it myself, or was there an alert? And in this case, we were very promptly alerted that everything was terrible, so we were good with detection. On diagnosis, this is from when I'm alerted to when I figure out kind of what the root cause is. How long does that take? This one, in an ideal scenario, you get an alert and it comes with a playbook, so that when you're up groggy at 3 in the morning, you look at the playbook and at least it gives you a direction to head in. We did not have a direction or a playbook for this particular scenario yet. Okay, before we dive into how did we fix the issue, I want to show real quick how we do log storage at Dropbox, because it's a little different, because we are a storage company, and we do in fact store logs in Dropbox. So we have what we call an S3 abstraction layer, and what it does is it presents an S3 compatible API to Loki, and it's smart enough to know for a particular service where the logs should be sent. So for Most of the logs, they go to this block here at the bottom that says MP. MP stands for Magic Pocket, and it's our highly scalable exabyte scale storage that we run on-prem. The S3 abstraction layer sends other data, like indexing data, to S3. We also have to be careful that we don't store Magic Pocket's logs in Magic Pocket, because that would not be good for people investigating incidents with that service itself. So one benefit we get here is on the S3 abstraction layer, if for whatever reason that on-prem storage was unavailable, it'll automatically fall back to writing the logs to S3. And we were definitely going to need that capability here, because about 30 minutes into the incident, connectivity was restored. But it was taking a little bit longer for us to connect to our on-prem storage in that data center. And so what was good about that is that all the logs for all the services were going to S3. So we were able to give our developers access to the logs that mattered now, like from post-incident forward, at the cost of having a little bit of delay in getting to those historical logs. So we run this, and what ends up happening is, the on-prem storage comes back up, and we were able to backfill all the things that were in S3 into Magic Pocket and have that just continuous line of uninterrupted logs. So that was really nice to have that redundancy kind of built in for us. Up to this point, I really left you guessing as far as why did the data center suddenly lose connectivity? I've come up with some examples here that might be misfortunes. It is, in fact, just a physical building, so earthquakes or fire or flood. Our case was a little more mundane. It was a power outage. And I say just a power outage, but the most highly reliable data centers, considered tier 4 data centers, are 99.995% uptime. And that translates to 26 minutes a year of downtime. And this is despite all the built-in redundancies that come with these. So they usually have redundant feeds from the utility company for power, redundant connections to the internet, generators, redundant cooling systems, battery backups, like all these things. So this was a really freak accident where enough of these things had failed that all of our servers in this data center went down for 30 minutes. And really, it was a good learning experience for us. I wish we'd been better prepared for it, but it really gave us an idea of what we needed to do to make this better in the future if this happens. And so that's the fourth step of incident analysis that we look at, and I think is the most important, which is prevention. Prevention is about figuring out what was the root cause, and then let's come up with some action items to make sure that doesn't happen again. And actually then doing those action items. I feel like the road to ops hell is paved with good intentions. So doing this allows us to keep things under control in the long term by addressing the root causes of incidents as we go, keeping things sustainable. So we know what we needed to do. We needed to have Loki in multiple regions. So the idea and the plan was two-region Loki. We were going to use DNS to point Promtail at Loki, and this DNS would have a configuration switch where we could basically switch it over to a different region and have very quickly all that converge to a different region. And a key part of this was we wanted to perform a disaster readiness test, because if you haven't tested it, it's probably broken, and I'd rather the first time we run this not be when a data center is down. And so we came up with a nice playbook of this is how to kind of orderly do this test such that our users wouldn't really notice, but we would get a better understanding of how it would perform in that situation. Okay, so just to give a little more detail here about how we did this, we have all our production hosts on the left, It's kind of hybrid cloud, so each one of these hosts has an agent on it, which we've talked about, Promtail. We're working on the Alloy migration right now. But each host could have multiple services on it, and they're all reporting their logs through Promtail to Loki. On the other side, the user side, we have Grafana and LogCLI that are both using DNS to talk to Loki in region 1. And then we have the object storage here, and that's going to be shared between both sides. So for the S3 side, we get some location diversity through S3 availability zones, and then on the Magic Pocket side, we get some free cross-region replication. So we didn't want to duplicate all the data in storage because that would be expensive. So we run the test, we switch it over DNS to region 2, and then we are able to see very quickly logs converging. But one thing that's interesting here is that in this case, where region 1 did not lose power, you've still got a good bit of logs that are still in memory that haven't been flushed to object store. So what we do is we manually kind of kick and restart the pipeline in region 1, and this causes a mass flushing of logs, which we had to kind of make up with our on-prem storage team a little bit and get some rate limits put in place, because when we do that, it is quite the torrent of logs. Okay, so let me rewind back to the beginning. Why did we choose Loki? Historically, our developers have been using SSH and VI or transferring files, off of a host. And this just wasn't going to be sustainable going forward. We were locking down production access, and we were migrating to Kubernetes, which has much more ephemeral logs with pod logs, which can easily come and go. So number one reason is Loki is based on object storage, and it's something we can easily understand. We know how to scale. We know what the price kind of dimension is there, so that was huge. Second is the strong multi-tenancy support. So this gives us a couple things. One, it lets us segment what logs developers have access to. Privacy is super important, so we want to make sure that developers only have access to logs where they have a need to know. Second, it gives us the ability for each tenant to set different limits, and this helps us protect the reliability of Loki overall. Okay, and finally, tight integration with Grafana. We've been using Grafana a really long time. Our metrics system has a custom data source plugin for it, and we definitely wanted to have a single place for observability, logs, metrics, and traces. And Grafana just seemed like it's going to continue to be the best solution for that. So that was why Loki. Let's go real quick through a whirlwind tour of plan to production. The plan, we started with a request for comments document. These are documents we do internally to get feedback on major changes that we're going to make. And it also allows us to kind of lay out, here are the different alternatives we considered and why we did not choose those alternatives. So we did a really thorough investigation into different SaaS platforms and heavier indexed logging solutions, and Loki just really stood out as the solution for our scale and what we were trying to do. So it made it a pretty easy choice. A key part of the design was making sure it was highly available. We wanted it to be something our developers could trust in. So part of that is taking really tight and strict control over the labels. So our label schema is based on where a process is running in our network, like a service, what host it's on, those kind of things. And the key there is that we're maintaining total control over cardinality of labels that come in. Cardinality being the combination of unique labels. If you have an explosion in cardinality, it can very quickly overwhelm your ingestion pipeline, cause things start running out of memory and ruin the fun for everybody. So We started with some pretty strict limits that weren't the most popular. So we started with a 7-day retention and some really restrictive query windows, like 6-hour max query windows across logs in Loki, and we had limited amount of chunks that you could fetch per query. And then we were also enforcing limits on the ingestion side. So a particular service has a global cap on the number of logs that it can send us before we start rate limiting, as well as a per stream limit. Stream is roughly a file in this case, where we will limit them that way. We've talked a little bit about privacy already. MTLS was a big part of that from the beginning. So mutual TLS is where a client and a server send a certificate to each other, so you're authenticating on both sides. And we had our Promtail pipeline set up to add a tenant ID to the logs, and in the design had chosen that would be the service name. We've got roughly 1,000 services in Dropbox, and this was a good tenant for us to kind of break things down by, and there's good ownership there. A key for us adding this tenant ID was the ability, we wanted to have a single data source that would serve all of the different services logs. We didn't want to have to manage a really long list of Loki data sources. So what we did is we came up with a custom proxy in Go, and it sits in between Grafana and the Loki query front end. So for each query that comes in from a user in Grafana, we look to see, does it have a service label? If the service label is missing, we mandate it. So we send them back a nice message that says, please specify a service. If the log does have a service, we will then look, does the user have access to the logs for this service against our custom permission system? If it does have access, then we will add the tenant HTTP header to the log message and send it on to the Loki query front end so it knows which tenant we want to query. If they don't have access, what's nice about a custom proxy is we can put in our own error message that points to documentation for how do you get access to these logs. Okay, as far as rolling this out to production, our main lever of the speed of that was how many hosts were we putting Promtail on at a time. And so we would be deploying to like 10 or 20,000 hosts at a time with Promtail and trying to see, let it soak a little bit, at least a day, sometimes more, and observe how is Loki handling that load. We had some alerting in place to detect higher write volume because we wanted very quickly to know if we were sending a lot more data to S3 than we thought we were going to be. One of the things we found as we were rolling this out is that some services were writing logs to disk so fast that it was filling up the disk. And so we realized we needed some runtime configuration where all the Promtails would be listening for this configuration, and we could switch it and immediately have Promtail ignore the logs from this particular label set or whatever. And that allows us to protect Promtail and protect Loki more broadly by giving us the ability to just quickly shut something off. Okay, I got busy with the AI again. So in this example, let's say that the lanes represent a service and the cars are logs. There's one service that's having a bit of a problem. Let's say that's rate limiting, 429 error message or something. So this is, in Promtail, when that happens, it will do exponential back off and then retry to send that log. The problem was a problem called head-of-line blocking, where when it was doing that, none of the other services could send logs. So we put up a pull request that, in this analogy, opened up all the lanes so that one service could be heavily throttled and the others could continue sending their logs. And a core tenet of multi-tenancy is that one badly behaving tenant doesn't ruin the experience for everybody. Okay, this was an issue that very nearly kept us from rolling out Loki to production. And So in the video here, you can see like we drop down, we get that required service label selected, and then we click on the next thing in Query Builder, and it's just spinning like for a real long time, and it was timing out most of the time. And this was like, this isn't going to cut it for our user experience. Fortuitously, we had a colleague introduce us to some folks at Grafana Labs, Owen Deal and Ed Welch, and like, wow, the timing. They were actually working on a solution to this very problem when we talked to them, which was to pull the Prometheus time series database in to replace BoltDB in Loki. And when we transitioned to that, we saw an order of magnitude improvement in our performance on label queries. So they saved our bacon, and we're very appreciative to them for the timing at which they were implementing that feature. Okay, once we were able to get past that, we felt like we could roll it out more broadly. So we send out emails. We see our number of weekly active users starting to tick up. We allow everybody into Loki, where it had been previously kind of early adopters being manually added before that. We have internal documentation ready that really explains like what the labels are and how to build your query with the label schema that we have in place. And then really important, we have extensive monitoring in place, those alerts that went off on the very bad day. So that it's not only for when we're breaching SLA on Loki and Loki's not acting right, but we also have alerts in place that automatically inform the teams that own a service that their logs are being rate limited. And so what that allows them to do is look and see, like, is there something recently that's been added that made my logging volume spike? We give them a nice dashboard to see where the source of the logging increase is. Or it gives them the ability to request a limit increase if that's what's needed. So we knew we weren't going to be able to anticipate 100% of like how this was going to go after we rolled it back. Those limits were very, very unpopular. So we were able to relax those. Bringing in our on-prem storage as like a second backend really helped us with that. Gave us better query speed, and we were able to expand retention out to 30 days and relax a bunch of other limits. Some tenants were much larger than others, both in terms of number of hosts, volume of logs, number of streams, and there was kind of that same label query speed issue with these because there was just so many combinations of labels in a single tenant. It was the same problem again. So what we did was we subdivided these really large tenants into like sub-tenants for the service, which really helped with that. A really critical way that we tried to get feedback as we were rolling this out was developer experience surveys that we sent out once a quarter, and that helped us get some very targeted feedback onto unfiltered thoughts on what people thought of Loki and the experience with it, and we've been able to make steady progress here in increasing. And that's been a huge way for us to figure out where to invest in future work on our Loki cluster. I'll touch briefly on a couple of reliability issues just because they were kind of tricky. One was we were using etcd for our Ring membership because we deploy Loki distributed so that we can independently scale query and ingestion side. And with this etcd cluster, like we had such a large deployment that we were very quickly reaching the limits of what that etcd cluster could do, and we were running into like limits on how much we could scale it. And so we switched over to member list option for that from HashiCorp. And that's part of the Loki config, and that like really increased the reliability of Loki. Another reliability issue that we had was with I'm going to skip for time, sorry. Okay, so at the end, it's time to shut down the old logging system. This is the hardest part of the migration because you're never going to make 100% of the people happy. And so one of the difficult use cases that we still have a little bit of trouble with is the needle in a haystack query. So some users are like, I want to be able to scan multiple terabytes of data for a unique ID, like a request ID, and I want that query to come back in a reasonable time. This is something that we're really looking forward to in coming features of Loki, to be able to give us better ways to, like through Bloom filters or whatever, be able to very quickly look up kind of by an ID like that. Okay, finally a Grafana panel, or it didn't happen. This shows logging volume from 2022 to present day. Slow increase, but now we're up to about 5 to 6 gigabytes per second for scale. And with our 30-day retention, we have somewhere between 4 and 5 petabytes of logs at any given time. Excited for what's coming forward with Loki, looking to transition to the Helm chart. If you have questions, we'll answer some now, and I'd be happy to talk at the Ask the Experts booth. Thank you.